All right, so in our first objective of topic 1, we talked about population distribution and the factors that affected, where people settled. What we're going to talk about in the next two objectives is population density. And how that is calculated. So, objective number 2 is to define methods geographers use to calculate population density. Population density is the amount of people in a certain area, and that's usually a square mile. But it's important to understand how the land is being used and if all the land can be used. So, there are 3 methods of calculating population density, and we're going to go into each of those in a little bit more detail. But there's arithmetic, physiological, and agricultural. Sorry, I had to pause for a second. There are 3 methods, and we're going to go over each one of those and why they're important and actually the limitations that they have. So, the first type is arithmetic population density. I guess you could say arithmetic, but I'm pretty sure it's called arithmetic. But this is your basic population density, and if you see maps on population density, this is how it's being calculated. They take the total number of people and they divide it by the total land area, and that gets pretty much how many people live per square mile. However, this type of population density calculation does not tell us how these people are distributed over that piece of land. So, is there an even distribution? All of these squares are showing, I think, 10 people per square mile. So, is it evenly distributed? Is there clustering? Are they clustered in one area? Is there a linear distribution? I know this seems like odd, like why would they settle that way? But you will see this like along rivers or roads, stuff like that. You will see, I say roads, like people don't live around roads, like obviously they do, but you will see, especially like along rivers and stuff, linear distribution. But this does not tell us, how people are spread out over that square mile. It just tells us how many there are. It also doesn't tell us, if it uses all of the land in its calculations, but not all the land is suitable for living sometimes. So this is a global map of arithmetic population density. So using just the total number of people divided by the total land area that each country has. This is this would be the population density map that you would get. I want you to look at this chart real quick because we're going to be focusing on the United States, and then down here, if this would get out of the way, oh, I can't even see it. Goodness. I think it's Niger. I'm pretty sure. Or Singapore. I don't remember which one it is, but we're worried about the numbers here anyway. So you will see that it's showing us the arithmetic density of both. All right, so the United States has an arithmetic population density of 84 people per square mile. That's not very many. And then this mystery country down here that we're not really sure because I can't remember. I think it might be Singapore. Has 19,982 people per square mile. So that's the difference in arithmetic density. Now, the next type of population density is physiological population density. This one's actually the most useful because it takes the total number of people and it doesn't divide it by total land. It divides it by total arable land. And arable land is land suitable for growing crops. So it's land that can sustain life. The physiological density is more useful than arithmetic density when trying to determine a region's carrying capacity. And a carrying capacity is the population a region can support without significant environmental deterioration. So physiological population density tells us like how many people are actually surviving on the amount of land that is can actually produce food. And so what they find out, when doing this is not all countries can produce enough food to feed all of their people. And so then they realize that they must import food. But that's what physiological density tells us. This over here kind of gives a good illustration. So this is arithmetic population density. It's saying that with 200 people, and there are 2 people per square mile. So you feel like you have a lot of space. However, this is actually showing us that these 200 people are living on 10 square miles of arable land. And so the physiological population is way more dense than the arithmetic population density. So if you put that in the calculations, this would be the arithmetic population density map. You can see how that changed. So this is regular population density. This is arithmetic population density. Now I knew it was Singapore. Look at me. Now when we look at this, we can see, because we've been looking at the United States and Singapore, that the United States goes up a little bit to 498 people per square mile in physiological density, but Singapore goes to 2,498,000 people per square mile on arable land. So that's a huge jump, and that can cause countries, a lot of humanitarian crises, and the fact that they have to depend on other countries, for food importation and stuff like that. The last type of population density is agricultural population density, and this takes a total number of farmers and divides it by the area of arable land. So this compares the numbers of farmers to the area of arable land and provides an indication of the efficiency of the region's farmers. So the trends that you'll see are that developed countries actually have less farmers taking care of land because of technology. But less developed countries have more farmers because they have to use like hand labor and they don't have as much technology. So this population density gives us an idea of the development of the country and their efficiency in farming. And so this is a world population map of agricultural population density. So make sure you do that summary of this objective before you move on to the last one. Email me if you have any questions.